Okay, so this video is all about a second method on how to solve a non-right triangle. So the first method we've talked about is using law of sines. Law of sines is method one if you do not know that you have a right angle. So, or you know you don't have a right angle. So method two is something called law of cosines. Okay, so method two for non-right. And we can use this to solve for an angle or a side that we do not know. Okay. So with this one, we would solve whether it's side angle side or side side side. That's the information we know. We know an angle on the two sides, one on each side of the angle, or we know all three sides. So essentially, if you don't have a pair of an angle on the side opposite and then another pair like that, you cannot use the law of sines, so we would most likely use the law of cosines. Okay, so just hopping right in, we've got our formula, law of cosines. So that is c squared, now this is lowercase c squared, equals a squared plus b squared minus 2 times a times b times cosine of angle c. And I'm going to over-exaggerate that c so you know the difference. That this c is a side and this c is an angle. Okay. Second thing to notice, that these two are also across from each other. So across from each other. They are corresponding angles and sides. Okay. So if I'm solving for an angle, I need to find the side across from it, and notice that is all the way across the equation from it. So they are on opposite sides of the equation, opposite sides of that equal sign. Also, if we take note of this, A and B are just the other two sides. So A and B, those numbers can be in either order. It's just the other two sides of the triangle that are not opposite or across from the angle that we either have or we're solving for. So again, there's two types. It's when we're given two sides and the angle in between, or all three sides when we will use this formula. So if we hop down to example one. Example one, I notice I know an angle, this angle right here, angle x, and I know the two sides next to it. So this would be an example of when I'm given side angle side. Okay. And so to help me decide, and if I bring this formula back up, since I know the angle, that's where this C is, angle C, put that in the cosine function. I want to know what side should go across from that. So I recommend draw an arrow to the side that goes across from angle 45, and that's x. So when I set up this formula, I automatically know I'm going to have that side length x squared equal to, and then all the way at the other end, it's going to be something plus something minus something times cosine of 45 degrees. Okay? So those two are on opposite ends. Then I fill in with the two legs. Now, like I said, it does not matter the order with the 11 and the 25. It's just that one of them needs to go in front of the other. So 11 squared plus 25 squared minus 2 times 25. Ooh, I'll actually put 11. Keep it in the same order. Times 25. Okay, so side goes all the way at the opposite side from your angle. Those two are opposite of each other in the triangle. So they're opposite of each other in the equation. Then the other two legs go in between. Since I have my variable all by itself on one side of the equation, all I have to do is figure out how can I get x by itself, and then put the whole thing in the calculator. Okay, so if I've got x squared, how do I undo square? That is with the square root function. So I'm going to take the square root of both sides of my equation. And so in the calculator, I can just type in the square root of 11 squared plus 25 squared minus 2 times 11 times 25 times the cosine of 45 degrees. When I type that in my calculator, I should get x equals 18.9. And that is the length of side x. Okay. So take a moment if you need to pause the video to type it in. I'm just going to keep going here to make sure I get the other two examples in. But pause it if you need to type it in. Check to see if you get 18.9. Good to practice that. Okay, so example 2. Again, I want to find r. So that's this side here. Okay. I notice that r is across from this angle 40 degrees. And this is another example of side angle side. So side angle side. Two sides and the angle in between, that's the information I have. So I circled the angle, draw an arrow to the side opposite of it, and that helps me set up my formula. So since I'm solving for a side again, it just so happens to be the variable. Most of the sides I have you solve for will be the variable all alone on one side of the equation. So that's r squared equals either one of the legs first, so maybe this time I'll do the larger one, doesn't matter. 32 squared plus 15 squared minus 2 times 32 times 15 times the cosine of 40 degrees. Again, I notice my variable is r squared. I just want to know what r is, so to undo that square, I take the square root of both sides. So I see this action happening. And so I'm left with r equaling the square root of 32, got a little ahead of myself, 32 squared plus 15 squared minus 2 times 32 times 15 times the cosine of 40 degrees. All of that is underneath that square root. Type that in your calculator, and you should get 22.7. Okay. So again, if you need to, please pause the video and check that. Okay. So examples 1 and 2 dealt with solving for a side. So when I give you side angle side, you will most often, actually you will be solving for the third side. But let's say I give you all three sides, and I want you to find one of the angles. Okay? So I know all three sides. Here, I'm going to tell you which one I want you to solve for. So I want you to solve for angle L. So I would circle the angle that you're trying to solve. Okay, so I circled my angle. That's what I'm going to put into the cosine function. Law of cosines, you're always using cosine, just in a whole formula. Okay. So to help me set it up, I need to figure out what is on the opposite side of angle L. So to do this, I look at angle L and I see, ooh, I'm going to draw an arrow to the side that does not touch that angle. And that side is 24. What is the purpose of that? Why would I draw that arrow? That arrow points to the side that will be all alone on the left side of my equation. Okay, so since that arrow is pointing to the side across from angle L, I'm going to put 24 and square that and put that on the left side of the equation. Okay. The other two sides, just like the examples up above, I'm going to take in any order and square them. So 5 squared plus that 27 squared. And then I subtract 2 times 5. I'll change that format. 2 times 5 times 27 times the cosine of the angle I'm solving for. Normally in example 1 and 2, I already had that angle, but now I'm trying to solve for that angle. cosine L. Okay. Some important things. Order of operations. Okay. Order of operations, if you recall. Okay, PEMDAS. So we start with parentheses. I don't have those, but then I need to go to exponents. So my first step for you, I would suggest taking 24 squared and figuring out what that is. So 24 squared happens to be 576. Then I would also calculate 5 squared and 27 squared. But the thing of how this is broken up is I know after exponents it's multiplication and division. So we can figure out what 5 squared is and what 27 squared is. Easy peasy. Okay? But then this minus throws into this 2 times 5 times 27 times cosine L. So the key thing here is that this is all grouped together and has to be taken care of before I can go to addition or subtraction. So when I take 5 squared and the 27 squared, I can add those right away. Notice those aren't being multiplied by anything, so I can just jump and add those together. So the 5 squared, which I know is 25, and 27 squared, I didn't actually calculate that in my calculator, but I added them together and I got 754. Okay, so those two can be combined because I'm just strictly adding those two numbers. The reason why I cannot combine that with the 2, 5, and 7, or 27 is because those are being multiplied times cosine L. So that cosine L times those three numbers cannot be separated until I get what I put in parentheses all by itself. So to see what I mean, you can still multiply 2 times 5 times 27, which is 270. I can multiply those and multiply it by cosine L, but I cannot subtract 754 and 270. You cannot because of this multiplication. This has to stay together. That 270 cosine L has to stay together until that's the only thing left on the right side. Okay? But with that said, I can move that 754 over to the left side. So to undo that, since it's a positive number, I need to subtract 754. And when I do that, let me scroll down just a little bit. When I do that, I get negative 178 is equal to that negative. So that negative comes from the minus right before 270, 270 cosine L. And remember, it's negative 270 times cosine L. So since those are multiplied, to undo multiplication, I think, oh, that is division. So I need to divide both sides by negative 270. 7 there. And when I do that, I'm going to draw this right over here. I get that 178 over 270. Notice a negative divided by a negative is that positive, is equal to cosine of L. And then I need to get L by itself. So to undo cosine, I take the inverse cosine of both sides. Remember, L is in that function. So I take the inverse, and I get L is equal to the inverse cosine of 178 over 270. And so L ends up being equal to 48.8 degrees. After I put that in the calculator. So again, a negative divided by a negative gave me that positive, but I'm waiting to put it in because it's going to be some decimal point, and instead of dealing with decimals and rounding and getting farther from the actual, that's what we're going to do there. Okay. I want you to either pause it and make sure you can type that in, get 48.8 degrees, but then I want you to try example 4, and with this you should get an answer of 69 degrees. I'm going to have a different video on how to do just that one. So if you get 69 degrees, you don't need to watch the next one.